Welcome, everybody. Welcome, welcome, welcome. Good morning, good afternoon, good night, wherever on earth you are. Thank you for joining us today. My name is Ethan Solovyev. I'm the Chief Innovation Officer at HowGood, and I am very excited to dig in with you today on artificial intelligence for biodiversity. This session is a souped up, redone, live on the web for the world version of an event that the speakers ran at Biodiversity COP16 in Colombia. It was part of the official Green Zone program. It was in the City Hall, the Chamber of Commerce in the center of Cali, Colombia. And we had a great, actually quite full auditorium. There were 10,000 or so people in Cali, even more, 15,000 for the biodiversity COP. We got a whole mix and cross section of them there. The solutions that we showed were so exciting for biodiversity that we thought we'd do it again for those who couldn't make it to Cali. So thank you for being here. I'm going to share screen and move us forward. So this is Artificial Intelligence for Biodiversity, a solutions showcase with a series of excellent speakers from excellent organizations. I'm Ethan Solovyev, Chief Innovation Officer at HowGood. We are also joined by Paula Andrea Paz, who is a research specialist at the Alliance of Biodiversity International and CIAT. Alexandra Alves is a researcher at Amazon. She'll be joining us via video. Chrissy Durkin is the co-founder and chief development officer at WildMon, and Philip TK, the CEO and co-founder at Courageous Land. I'm going to do a brief sort of intro overview on HowGood and artificial intelligence in general, and then we'll get into the solutions. HowGood is a sustainability intelligence platform that covers everything from carbon to water to labor risk to human rights to processing to soil health to biodiversity. In our software as a service platform, we deliver detailed impact data to the largest food and agriculture companies in the world. HowGood is a social network for food and agriculture impact that uses an enterprise-grade software as a service and data as a service platform for engagement and action. We have 18 years mapping out global supply systems. We're pulling from a huge number of different data sources and certifications, including from our longstanding partner, Biodiversity International, that Paula will speak from today. We have a massive number of on-farm impact factors for food ingredients and have assessed nearly 4 million global food products. It is the world's largest sustainability database for food products and ingredients. Our great data brings us a great set of partners and customers, from retailers like Sonnet, Ahold Delhaize, and Carrefour, to food service distributors and restaurants like Chipotle and Cisco, to major global companies like Danone, Grupo Bimbo, Polig, and suppliers like Ingredion, Kerry, and more. All of them come through HowGood's platform called Lattice, which allows you to measure the impact of any food product in the world, disclose the impacts, track carbon emissions, and also other impact factors across scope 1, 2, and 3 in accordance with global regulatory requirements. The platform also enables supplier engagement and collaboration to help streamline and consolidate communications with your supply system, and especially now gather more and more primary data and get greater and greater visibility and transparency back to the origin. Through engagement with suppliers, there's the opportunity to reduce the impact on biodiversity, reduce the carbon emissions, reduce the water usage, and even support and uplift human rights, and then ultimately communicate that work out into the world. And you'll get a little 2-minute video of some of the AI ML algorithms that we're building into HowGood's platform at the end. Artificial intelligence is a general purpose technology, especially generative AI and the current growth of generative AI. This is a technology that is on the order of a wheel when humans created wheels, or when we got electricity, or when the first personal computers came to play. Generative AI is this level of change and disruption coming for the whole globe, for the people of the globe, especially for the economy and political systems. Generative AI is a general purpose technology that can affect an entire economy. They have the potential to drastically alter societies through their impact on the pre-existing economic and social structures. So not every solution you'll see today is directly generative AI, but it's worth noting that we are in an incredible moment of change where, 80 years ago, 80% of the jobs that we all have today literally did not exist. And it will be similar, but it might not take 80 years into the future. The structure of work and society is transforming and will continue to. Many people run away from this and are sort of like, I don't want to deal with AI. I'm not interested. It's dangerous. What about this? What about that? With many concerns about it. I think that it's not the particularly most useful approach. I think we need to dig in on AI and put it to work for us, capturing carbon, regenerating ecosystems, lifting up human rights. We know that the extractive industries are making use of it. The food industry and the broader ag and nature industry should as well. HowGood has identified 3 levels of effects from artificial intelligence, which have an increasing potential for positive systems change. The first is efficiency. Most AI that's out there right now is really just efficiency. It's doing business as usual, but a little faster. It's more of the same marketing emails you're writing, but a little faster. It's more of the data processing you're doing, but faster. So a lot of AI that's out there right now is useful for efficiency and making things go faster, but isn't necessarily shifting or changing the overall arc of humans on the planet. The next level of effect is innovation. Here's where AI is used and helps create something that's actually new, that could not be done before, or could not be done before at a significant order or scale. The third level is transformation. I really want to see generative AI powering transformation of our businesses, business models, society, culture, the way we interact with and impact the earth and all of her beings and all of her people. So we're looking for opportunities where we can step up and not just do what we're already doing more efficiently, but actually go to innovation and transformation with our engagement with artificial intelligence. The question we're asking is, in this case, how can AI be used to protect, support, and regenerate biodiversity? And we know that the business world wants AI. This is one of HowGood's AI surveys. This is anonymized responses from organizations with combined annual revenues of over $300 billion per year. Everybody wants to use AI to execute. 88% want to use it to innovate. Some want to use it for transformation, and many are just curious. There are some constraints to considering AI, but there are also many business critical pain points that people want to solve. Product formulation, reducing costs, sourcing decisions, streamlining responses to customer requests, predictive analytics and visualizations. You'll see some of that today. The arc that we're going to be looking at and seeing each of the solutions looks at sort of a path from Earth all the way through material production, the growing of food or agricultural materials, going up through a supply and value system and to an endpoint where products are sold and used. More specifically, we can think about how we might use AI to protect nature, to prevent deforestation and land use change. We might say, well, could we use AI to monitor and understand biodiversity as it currently is, as it's changing? Could we enhance the sustainability of supply chains using AI, or even regenerate ecosystems or create products that support biodiversity? So as we head into the solution showcase, you'll see that Previsia and Terra-i are in this realm of protecting nature, preventing deforestation, also monitoring and understanding biodiversity. WildMon plays very strongly here, but also has applications to enhance supply chain sustainability. Courageous Land has incredible work to do regenerating ecosystems, transforming damaged or barren land into intensive, productive agroecological systems. And then HowGood's platform Lattice helps companies actually redesign their products, formulate, reformulate, innovate products that support biodiversity back through the system. So this is the solution showcase that we're going to see. Without further ado, I'm going to hand it over to Paula. Each of our presenters is going to have about 6 minutes. I'm going to work the slides. As if we make it through in good time, then we'd love to get questions. Also, in the chat, please add some questions if you have them as you see the different solutions. Paula, let me know when you want me to move the slides, and over to you.
Okay, thank you. Ready. Hello, my name is Paula Paz. I'm a research specialist at the Alliance Biodiversity CIAT. We are based in Colombia, and I work in a digital inclusion research team. I work in a project which we work with a satellite imagery, with remote sensing, and with AI models to create information about the agroforestry monitoring and deforestation monitoring. I will present the Terra-i Plus. It's a satellite-based solution for agroforestry supply chains sustainability. Next slide, please. Yes, just for one introduction and that context, this project born with the high demand on increasing for accessibility data to respond to different needs, such as certification standard, like the UDR certification on zero deforestation. And also it started the needs to have high accuracy information to know where is the crops, where is the coffee, where is the different commodities like a coffee, cocoa, oil palm that has it has a major impact in the deforestation. So increase the needs to have this kind of information. And how to create this information is using the remote sensing and the AI models. Next slide. So this kind of information has a big challenge because it's really hard to identify in a satellite imagery to try to difference where is the agroforestry coffee, where is the forest, and also where is the cacao and agroforestry cacao. So it's too hard to identify with a satellite imagery because also the pattern is very similar and the signal bands is really similar to identify the different crops. And currently we have a Europe Global Forest Cover Map for 2020. And we have information globally about where is the forest and non-forest, but this one team have validated this kind of information and found that this map may misclassify more than the 50% of we know the coffee farms like a forest. So increase the needs to have more accurate information of that. So how we can have high accurate information is to calibrate the models, is to include the field data, is to include to the organization that is in the field to have that geo-reference points with a high information where we can know that where is the crops, where is the forest.
Key commodities traders are racing to comply with EU deforestation-free regulation, as well as sustainability standards and certifications. They are also under pressure to meet net zero carbon commitments. Environmental risks such as climate change or water degradation are also key problems. Terra-i Plus provides a satellite-based solution to these problems. The tool helps users monitor supply chain sustainability by providing high-accuracy maps at local scale through the application of advanced custom AI to remote sensing. The tool was co-designed with actual users to produce a user-friendly interface and metrics tailored to different use cases. Terra-i Plus can be used to benchmark jurisdictions against each other or to analyze at farm level based on user-uploaded farm location data. Now, let's take a tour around our Terra-i Plus tool. To customize the analysis to your supply chain, upload your farm location data first. Choose the metric with which you would like to evaluate your supply chain. For example, likelihood of non-compliance with EUDR. First, select the dataset you wish to analyze. Select the aggregation level you want to break the analysis into by province, district, certification, or other levels. Select the area of interest. Then click Analyze to see the results. The graph and explanation text easily points you to places where there is higher risk of UDER non-compliance. In this case, it's Dak Glong district. Click on the bar chart to take you to the respective area on the map. Zoom in to see farm polygons information. For example, this farm has very high likelihood of non-compliance with the EUDR. The map shows brown deforestation raster inside this farm boundary. Click Open to see detailed definition of each non-compliance likelihood level. The tool can also export your data to various formats, for example, CSV files or PDF reports. Data description is also available for download. The same analysis can be done at jurisdiction level. If you are interested to identify opportunity area for agroforestry projects, our shade tree metric is the right spot for you. To compare jurisdictions, you won't need a farm location dataset. Simply select the aggregation level and the areas of interest, then click on Analyze. The result shows that Lam Dong province has the largest coffee area under less than 5% shade canopy cover, as represented by the purple color on the map. Click Open to see shade levels definitions. The shade levels are calibrated specifically for each country's context. Similar analysis can be carried out for many other use cases, such as future climate risk and adaptation, surface water pollution risk, recent deforestation events monitoring, carbon gain estimation, and land cover categories area estimation. For more information, contact us at support.terra-i@cgir.org.
Yes, no, the last video is the showcase, the demo of the Terra-i Plus. So the main objective of the Terra-i Plus, like you see that, is to integrate the local knowledge with the AI models, and we use deep learning models to create Sentinel data, Sentinel-1 and Sentinel-2 to create this kind of information, the coffee and cocoa maps, and also the deforestation. We create a bi-weekly data of deforestation, and the tool have been implemented in Vietnam. The example that you can see was in Vietnam. We use organization information farms of coffee, and we started to evaluate what is the deforestation and if the farm has or not deforestation and can apply to the UDR. So this is a faster examples. The first one is the land cover map to identify where is the coffee and the forest, and another one is another metric that I mentioned is the mapping of the shade trees. Is when we identify where is the coffee, we want to identify which of these farms of coffee has or not shade trees, and this is a great opportunity to have a carbon project. So the second innovation is to know what is the level of the shade trees in the coffee farms. And the next one slide, we have another approach, is the sample earth. Like I mentioned, that it's to have a high accuracy data, we need to create a good reference data. So our idea is to started to create a reference data polygons with where is the coffee, where is the cocoa and the forest, and then this kind of information is can use for the for training our models and to create a more high accuracy quality data. And the next one is just an example of the tool where we can show the organization of the coffee, and this example is in Vietnam, can upload the polygons of the farms and can start to analyze if the farm has or not deforestation, and in which data was deforested, and also it's just to invite it to visit us. Our website is Terra-i Plus, and you can see more information about our methodology, how we created the maps of the commodities and also the methodology, how we created deforestation data. And this is all for my part. Thank you so much.
Excellent. Thank you, Paula. And we'll get your contact info out there. Also, just to note that the Alliance Biodiversity and SEAT long-term partner of HowGood's, one of the global UN CGIAR research centers, doing incredible work, not just in AI and biodiversity, but across the saving of seeds and crops, and a huge amount of research. They also have an agrobiodiversity index that HowGood works with and makes available in our platform. So thanks, Paula, for joining us. I'm going to step on, pardon me, to the next solution here. Previsia, unfortunately, Alexandra wasn't able to join us today. We've got a great little showing both of the tool and her describing of it. I first heard of Previsia when I was looking for innovative solutions and what AI was actually doing that was good, not just a little bit better business as usual. And I heard about this outfit that was preventing deforestation using actual artificial intelligence, not to figure out what to do afterwards, but to figure out where deforestation was going to happen before it happened. So in connecting with Amazon, the organization that developed the tool, we've been glad to get to know Alexandra, and here's a little overview of what Previsia can do.
Olá, eu me chamo Alexandra Alves e é um prazer estar aqui na COP16 apresentando a nossa plataforma de previsão do desmatamento, a Previsia. A ferramenta combina ciência de dados e inteligência artificial para identificar áreas sob risco na Amazônia brasileira e, com isso, ajudar a manter a floresta em pé e a biodiversidade preservada. A Previsia utiliza diversos tipos de dados para gerar suas previsões. Entre eles estão informações sobre uso e cobertura do solo, variáveis socioeconômicas e a presença de estradas, tanto oficiais quanto não oficiais. Esses elementos são fundamentais para entender a dinâmica do desmatamento e prever onde ele pode ocorrer. As estradas, por exemplo, desempenham um papel importante na expansão da devastação. Estudos do Amazon revelam que até 95% da derrubada na Amazônia ocorreu em até 5,5 quilômetros de uma estrada. Porém, o monitoramento das estradas não oficiais era lento e manual. Agora, com o uso de algoritmos de inteligência artificial, conseguimos automatizar esse processo. Com isso, o que antes levava meses, agora pode ser feito em poucas horas. As estradas mapeadas manualmente foram utilizadas como dados de referência para treinar o modelo de Deep Learning como a Unity, uma arquitetura de rede neural convolucional projetada para tarefas de segmentação de imagens. Durante o treinamento, o modelo recebe imagens do satélite Sentinel-2 e a camada de referência, que é o mapeamento de estradas manual. Isso permite que sejam associados padrões visuais da imagem com a perspectiva classe de mapeamento, que são as estradas não oficiais. Após o treinamento, o modelo é utilizado para fazer novas inferências automáticas, ou seja, o mapeamento de novas estradas. Os dados coletados são processados pela Previsia para criar mapas iterativos de risco, com escala de 1 km para cada pixel. Nesses mapas, os usuários podem visualizar as áreas mais ameaçadas, com a previsão de desmatamento para o próximo ano, e também explorar gráficos detalhados e relatórios, que ajudam a entender melhor as dinâmicas locais. As áreas são classificadas em 5 níveis de risco: muito baixo, baixo, moderado, alto e muito alto. Previsão que tem tido grande assertividade. De todo o desmatamento ocorrido na Amazônia brasileira, 16% ocorreu dentro dos pixels previstos pela Previsia, e 74% ocorreu em até 4 km desses pixels, distância curta para ações de fiscalização. Os polígonos da cor preta representam as áreas desmatadas sobrepostas à base da Previsia. Observem como o desmatamento se concentra nas áreas de risco mais altas previstas pela plataforma. Esses resultados reforçam a precisão do modelo e o seu potencial para guiar ações preventivas com mais eficácia. Além de pautar a imprensa nacional e internacional, os dados da Previsia motivaram a assinatura de termos de cooperação com 5 ministérios públicos dos estados da Amazônia, sendo eles Acre, Pará, Amazonas, Mato Grosso e Rondônia. Dessa forma, a Previsia não é só uma ferramenta de combate ao desmatamento, mas também uma grande aliada na preservação da biodiversidade. Ao ajudar a manter a floresta em pé, estamos protegendo milhares de espécies que dependem da Amazônia para sobreviver, garantindo que seus habitats sejam preservados para futuras gerações. Saiba mais em previsia.org.br. Muito obrigada!
All right. Well, hopefully you enjoyed learning a little bit about Previsia. I think it's incredible, the map with the overlay of like, here's where we predicted deforestation would happen, and then here's exactly where it happened. So we would love to see more and more uses of AI in protecting natural resources, along with understanding them. And to take a little bit of a look at how artificial intelligence is being used to map and understand biodiversity and much more, I'm going to pass it over to Chrissy Durkin. Let me know when you want me to move the slides.
Hey everyone, thanks Ethan. You can flip to the next one. And agreed on Previsia, it's pretty incredible. Thank you Ethan and the HowGood team for having us as well. I'm Chrissy, I'm the Chief Development Officer from WildMon. We are a nonprofit tech startup really focused on improving how we're able to measure and track fauna in particular. So you can flip to the next slide. We've all really come together, especially through COP, around this problem, which is the biodiversity crisis, right? We're all quite maybe a little too familiar with it. And I really believe to solve it, we need to fundamentally change the way that we are interacting with all sorts of landscapes globally to create much better results for nature. And one of the biggest keys there is actually understanding what is happening within ecosystems. At present, it's still extremely challenging at the local level to know what is happening with ecosystem health and especially fauna, just because it's so complex and hard to monitor. So our organization has really come together around this local challenge. How do we make it way easier in a standardized way to collect the data we need to understand what is happening at the local scale so that we can make much better informed actions on the ground around preserving and protecting fauna? And how are we able to use that data to create much better sustainable livelihoods and to create positive nature action in the land uses around the world? So next slide. Our team has really come together around the three most scalable technologies for measuring fauna, which include acoustic data, camera trapping, and environmental DNA. These three have really risen to the top as the best ways to collect information from the ground on what is happening with birds, frogs, bats, mammals, insects, and each technology is quite complementary actually in making up that sort of full picture of what's happening. Acoustic monitoring, thank you, is great for birds, frogs, bats, any vocalizing species. Camera trap is great for usually larger ground-dwelling mammals. And DNA is an incredible technology that makes it possible to collect samples from the field and then analyze those for DNA presence, making it possible to map insects, aquatic species, and more so mammals and vertebrates, all sorts of different species based on the sample type. So together, you're really painting a picture of most of the fauna that exists in a forest. However, you're dealing with massive amounts of data. So this is really where AI comes in. And you can flip to the next screen and start playing the demo while I talk through this. What we've done is essentially built the data infrastructure and pipelines to be able to manage and aggregate these three data sets at scale and use artificial intelligence to help automate a lot of the processing of those data sets to make it much faster, more accurate to understand what is happening with biodiversity across those three different types of data. So for example, we're able to take huge amounts of acoustics recordings, slice and dice that into which species are present and when, and then generate all sorts of metrics and indices as a result of that. The same we can do for camera trapping and eDNA, and essentially what our team has been doing is building an integrated dashboard, which is what you're seeing right now, around how are we able to interact with these three data sets simultaneously and look at them in conjunction. So this is displaying a project that was collecting data on both camera trapping and acoustics, a project in Brazil. And essentially you're able to look at the species level, what is happening with presence and change over time, but then you're also able to aggregate those data sets to look at more advanced metrics as well. And we're currently developing the next version of this platform, which is integrating more geospatial data and able to also use AI to automatically calculate additional metrics for pulling into all of these different reporting requirements and all that good stuff. But the focus is really, how are we developing this technology so that frontline conservationists, farmers, boots on the ground can actually collect the data themselves, put it into the system, and really go from start to finish without having to have, a huge bucket of money, a ton of external expertise, coding scientists to be able to make use of all this data and actually create outputs that can be implemented through action, and then also through all these reporting needs. And so that's the focus, is how do we remove the need for external expertise and put these tools directly into the hands of the people on the ground who can make use of them. So this is essentially a way that at the project level, all of those stakeholders can make use of the data themselves. You can flip to the next slide. So we're currently doing this in quite a few projects around the world with all different kinds of applications. So some of those are directly in agroforestry projects, looking at how are different planting methods impacting biodiversity health and what does change over time look like. Some of those are within protected areas. Some of those are in response to a specific endangered species. The cool thing about these technologies is you're able to kind of choose which one is most effective and implement it to get the answers to the questions that you're looking for based on the needs on the ground. So one quick example, trying to stick to my 6 minutes. You can go to the next slide. One quick example is from Thailand. This is a project specifically in rubber agroforestry sites. It's a really incredible project with Terra-i, the VF Foundation, and it's essentially to look at how are better regenerative rubber growing practices impacting native fauna across farm sites. So it's a coalition of farmers on the ground who are interested in collecting this data, both to inform their own practices, but also to create higher value products that can be sold into the marketplace, specifically with Timberland, Vans, North Face, these organizations. So we've partnered with the local university, Terra-i, and a lot of local farmers to implement bioacoustic monitoring, which is a great technology for this application because some of the first species to return to these kinds of sites as agroforestry gets implemented are birds, insects, amphibians. These are all quite vocal species. So that technology was prioritized as the first thing to implement in these sites. And we'll be looking at using AI to automate all the analysis of those data sets and make it easy to continue to collect this data over time to see how, as the agroforestry practices continue to get implemented, how native fauna, the health of native fauna continues to regenerate. So you can go to the next slide. Again, this data is being used directly by farmers on the ground. We're excited to see kind of the result of that. It's still in the early phases, but then it will also be made available directly to the folks purchasing the rubber. So it'll be they'll be able to inform kind of how the practices are impacting the products themselves at the end of the life cycle of the rubber. So that's one example, and that's sort of what our team is focused on. If anyone is interested in exploring any piece of that more with me, my email's right there. Feel free to reach out. And again, thanks to the HowGood team for having us and for all of these other amazing solutions. I've been learning a lot. So I'll turn it back over to you, Ethan.
Thanks, Chrissy. Really amazing to bring the three together. There are certain outfits that are out there that focus on eDNA alone or focus on camera trapping alone. All are great and important, but the way that you're bringing them together into one platform, harnessing the strengths of each to see the whole picture, is pretty exciting and haven't really seen much else like it. So thank you for the work your nonprofit's doing, and we're looking forward to collaborating going forward. Okay, so for the fourth solution here, we're going to take a look at a little bit different use of AI that is focused on regeneration. And I'm going to pass it over to Phil, who's going to share screen, walk us through some slides, and maybe even get a little bit of a live demo. Phil, over to you.
Hey, thank you very much. And it's really an honor to be here with you guys. Thanks for taking the time. Ethan, if you could actually drive on the slides, I think it might be best for now. And then if there's time, we'll kick it over to the live demo. Thank you very much. Yeah, so my name is Philip Cowders, and I'm the CEO and co-founder of Courageous Land. Our mission is to help reverse climate change while creating health and abundance for life on Earth. And we do this by restoring degraded landscapes into biodiverse and regenerative agroforestry systems. The problem that we're here to focus on is that, as you guys know very well, the food system makes up about 30% of CO2 emissions and most of deforestation and biodiversity loss. But the good news is, Scope 3 reporting is coming into effect. And so we're here to help create products that are carbon negative through these regenerative agroforestry systems. In Brazil, where we're starting, it's even more pronounced. It's 74% of emissions in the country is from the food system. So just, one or two more slides of setup. So as you guys know, as you convert degraded landscapes into regenerative agroforestry systems, you're decarbonizing supply chains, increasing food security, rural earnings, resilience, biodiversity, water, soil fertility, and also consumer health. And so this is the backdrop of why we're using AI to really bring real world change. And our business model is dependent on both the production of agroforestry products, and then there's obviously carbon and other components to it in terms of monetization. Okay, so this is what leads us to the creation of our agroforestry intelligence platform. The setup is that there are some really key challenges to scaling agroforestry. And the first one is planning. So which trees can be added to that agricultural landscape? The second is financing. How are you going to pay for those trees? The third is how do you manage this new, very biodiverse set of tree species that have all different management requirements? And the last one is how do you get the production of both the carbon and more importantly, the agricultural crops into market? And so we noticed that all agroforestry projects had these exact same challenges, and therefore we built out our agroforestry intelligence platform. So all agroforestry projects, even though they're all very much location specific, context specific, they all follow the same process. Diagnostic, which is basically diagnosing the land, understanding what's possible there, going into planning that agroforestry system and financing it, managing the agroforestry system, and then selling the crops and the carbon. And the first thing we did is launch a free diagnostic for any farm in Brazil to understand their agroforestry potential. And if you scan the QR code, it'll take you to our website where you will be able to test with any land up to 10,000 hectares in Brazil what the potential is for revenue, which tree species are recommended for that particular farm given agroclimatic conditions, potential for irrigation, what the climate looks like today and what it's expected to look like in 2040, distribution of rain, wind, solar, altitude, erosion, biodiversity specifically as well, as you can see here at the end, so the intactness of the biodiversity. And so it's a really interesting way to get insights into a farm that were not previously available. So we used to do diagnostic of our own farms through in-field consultant specialist work, and that would take about 2 months and cost over $10,000. And now we're able to do it in 30 seconds for free and make it available to everyone else for free. So this really diagnostic of land. And then once we know what the potential species are, then we can build out in 3D over time lapse what the system will look like in reality. So which species we want to select. So here you're seeing Robusta coffee that in the beginning has banana trees, but those will leave the system and be replaced by acai, which are those palm trees there. And then we have high, tall growing timber species and coconuts around the outside, as well as black pepper. So super biodiverse systems that will sequester over the first 25 years, about 400 tons of CO2 equivalent per hectare, and be able to produce deeply carbon negative crops that allow companies that need to decarbonize their supply chain to offset their farms that are emitting carbon by matching it with our farms that can sequester carbon. And the idea of the platform is to really build out this network of farms that can do this on their own, and we give them the tools to diagnose their land, plan the system, finance it, manage it, and sell. And not only do we use AI to help diagnose the land and make the planning happen, it's very important for the management as well. So we're collecting both ground truth and then remote sensing data for each tree in our agroforestry systems. So that way we have the data that's necessary to do artificial intelligence and optimization of agroforestry designs, knowing which trees go best next to which trees, the ideal spacing, the amount of shade versus sun. There's a lot of different factors. And as you can imagine with agroforestry, when there's hundreds of potential species that can be planted and an infinite amount of arrangements on how they could be planted in terms of positions and spacing. It's a really interesting optimization question that requires data. And so we are at the forefront of this for agroforestry, and really excited with what comes next. And last slide. Just wanted to reinforce that even though, of course, the AI and the data and everything that we're doing is incredibly interesting, and we love doing what we do, we're doing it because it's the means to an end. We're doing it to change what's happening in the real world. The real world is emitting too much carbon. It's unsustainable, and there's a lot of shocks happening to agricultural systems. So how do we take AI and really make a difference in the real world in order to produce organic, carbon negative crops that are climate resilient, that are regenerative, that are great for biodiversity, and also create on-farm biodiversity through the tree species that are all mixed together, moving away from monocultures and into polycultures. Thank you very much. And if you guys are interested in learning more, please reach out.
All right. Thank you, Phil. Let's do one last solution, and then we'll do some Q&A with the group. I'm going to present, now we've kind of reached the far end of that diagram. We've understood and protected some natural habitat. We've really looked to understand the fauna that's happening with WildMon. Phil's got us regenerating landscapes and starting to talk a bit about the product at the end. Lattice, HowGood's sustainability intelligence platform, gives a way that product formulators and procurement professionals inside the major food companies in the world, and the small ones too, can look and understand, how do I improve my products? How do I create a more biodiversity friendly, a more nature positive food product using advanced AI ML algorithms? So I will narrate as you get a little glimpse into Lattice. So we're signing in here, getting an overview of our portfolio where we can choose a number of different metrics like land occupation, like water usage. We can dig into individual specific products and see what are there's cacao powder that's causing an impact in a particular product. This is a white bread. We can see the biodiversity score that it's currently getting, and then also see what the impacts are. So this is saying that there are some impacts for biodiversity, but then we can also do abatement strategies. So this is what's powered by AI, where we can pull up for every single ingredient in the product, from unbleached wheat flour to sugarcane to soybean. It will tell us where should we source that from ideally, where should we, what agricultural practices should be used, what standards should be used, so that we can get ideas about how to go and actually improve this product. So here we'll go in and change to a certified organic for the wheat flour, and you can see that immediately bumps up biodiversity. We can choose a different sourcing location for the sugarcane and a different certification as well. This time we'll do a regenerative organic certification, and this then increases biodiversity significantly. We can keep going and make a switch on soybean oil from Brazil to something like Canada. That's got a bit of a better score there. That will push it up and make it non-GMO. Each change that you make in the platform, which is recommended by the AI, can optimize it a bit further. So here we have a finished product that we can now save, as this is Kate's white bread, optimized for biodiversity. We can save that and actually create a scorecard that takes this product, this particular bread, compares it first against the one we had earlier, but then looks at it in terms of biodiversity. So you can see this bread has gone up significantly, and this then becomes a PDF that you can use to sell to customers in retail, or also to pass onward directly to consumers. So the artificial intelligence on top of the data that HowGood has built into the platform gives a great way for formulators and procurement professionals to make decisions about what they're getting and how to improve their products. Okay, we have made it through the set of solutions from HowGood, Terra-i, Previsia, WildMon, and Courageous Land. And we would love to open the floor for questions. I think that, so let's see if anything's in here in the chat. Chrissy's already answered a little. Phil, question over to you. Question on the carbon credits. Is the option to buy the carbon credits first given to the crop off-taker to count towards their insetting?
So the answer is it just depends on the timing, right? So if you want to do something, of course, bespoke and want to be involved from the beginning of that agroforestry system, you'll absolutely have the first right at it. And that would be our preference, is to always associate the carbon with the crops and to work with supply chain decarbonization. Now, of course, if the project's already, a couple of years old, somebody might already have, taken claims or wanted to buy those carbon credits through offsetting. So it just depends on timing, but we can build out custom projects.
Great. Thanks, Phil. A question for Paula. Who do you think is the ideal customer for your solution? Would it be a coffee roaster, an upstream trader? Who's the right person to use the Terra-i?
Hi, thank you for the answer. I think the both is the coffee roaster and also the different organization of coffee. And we started with coffee, but also we are thinking to implement it in cocoa organization. And also all the organization that are interested to work in the certificate.
Yeah, I think especially in those agroforestry crops, it really, makes a lot of sense. Question from Juliana here. Is Lattice available in other languages? Not yet. Getting there. We'd love to. We do take in data in many different languages from our global food partners around the world. We've had a whole bunch of different languages that we've translated in to use the data, but currently only in English. We'd love to have a partner customer that needs it in a different language so we can push that part forward. So if you're out there, let us know. We'd love to talk. Interesting question here from Carlos. How primary data-driven projects using the solutions we saw today can feed into Lattice so we can communicate biodiversity at the product level. Wow, that's a great question. I think I've got to respond to that one to start, but I'm gonna turn it into a question for everyone else. So this is a major push of Lattice and HowGood's platform right now. I'm gonna stop screen sharing there. A major push for Lattice is to gather in primary data from around the world, from really down to individual farm level. So we've just launched a new feature in the platform that's called Field Scope that allows users to input very detailed 60 different fields of agricultural practice data that include things like fertilizer usage, number of tillage, soil type, what pesticides are used, and then calculate a very farm-specific emissions factor. But it also has some biodiversity metrics. It also has some water usage metrics in it. That's in a partnership with the Cool Farm Alliance and the Cool Farm tool. So that's directly in platform. So if you're a user of Lattice, you can immediately get primary data from your supply system and put it into the platform. Or we can help you with supplier engagement going upstream to your suppliers and their suppliers and their suppliers to gather that primary data in. Now, if we want to get more biodiversity specific data in, well, HowGood's going to need some partnerships with the likes of folks on the line here who are really specialists in gathering that on the ground primary data. And then there'll be some mapping to do between HowGood's current nature metrics and the particular, very detailed information that the folks here are generating. We have a deforestation metric, we have a biodiversity metric, we have a water use metric. Do we have, specific fauna versus flora metrics? Do we have, ecosystem extent and connectivity, state of nature metrics in development, but not currently live in the platform? So there is a path to get primary data. And we need to work and collaborate with partners like the ones on this phone call to move it to the next level. Question for Chrissy. Have you all done any pilots in the coffee space? If not, any interest? Love that question.
Yes, thank you. That's a great question. We have not worked across the coffee space. We have a few conversations in the works around coffee, but most of our agroforestry collaborations have been so far around cocoa, palm oil, rubber, a few different kind of forest garden approaches, but the technology works similarly across different crop types. So absolutely lots of interest. Would love to chat if there are opportunities to collaborate specifically in the coffee space.
I'm going to ask a question to each of our speakers today. Maybe we'll start with Paula, go to Phil, and then end with Chrissy, which is, what do you see in the future? We're working at this intersection of artificial intelligence and biodiversity. Like, what's coming next? I mean, in AI, you don't look 10 years down the road, you look like 18 months. So I don't know, say 18 months, 2 years, 3 years. How do you see things continuing to evolve in terms of AI being used to support, protect, enhance biodiversity? Paula, you can start.
Yes, I was thinking that maybe I think that for the next time is to create more reference data, no? Because we have now all the AI models and big AI models, accuracy models, but the issues is the challenge is to where is the reference data. For example, for the satellite imagery, we need to create a database with a reference data, with a real reference point where we can know that if it's a coffee or visit another land use or another thing that, and at the end is that to create a database that it could be free and any person can use for training their models and to have a high accuracy and their results.
Excellent. Thank you. Phil.
Yeah, I think that the quality of the data and how cheap it is to obtain the data is only going to improve over time. And so I think we'll see close to real-time biodiversity metric monitoring at the farm level that hopefully can bring full traceability from the exact lot of product, of commodity that's coming off of that farm through the supply chain. I think that is not that far away. That's the hope.
Cool. Chrissy.
Yeah, well said, Philip. I'm excited. I mean, I'm super excited about generative AI and all of the capacity that it will bring to making it much easier to collect and analyze this data. I feel like we've barely scratched the surface. I can imagine a world in which it makes it so accessible that, you know, anyone with any level of expertise is able to collect and then get extremely useful outputs from these data sets without the need for you know, massive budgets that are making it pretty cost prohibitive to implement a lot of these technologies at the current state. So similarly agree, I think we'll move toward a world in which there's so much transparency that essentially the buyers will be able to make much more aligned choices around the products they're consuming, because you're able to have this sort of ability to understand exactly what the impacts are globally. So yeah, I'm quite optimistic about how AI is going to transform our ability to interact with nature.
Cool. I'm going to add my own response to this question in here. This is coming from some of the work that we've done both in our sessions on AI for the natural products industry, but also we've done a deeper sort of invite-only session that's on AI for regeneration in a broader sense. And one of the wild things we were looking at there is all the generative AI right now is trained from, or most of it is trained from their large language models. So the training data that goes in is all what's written. It's all what's out there, mostly on the internet, biased in the ways that the internet is. And it's also on human words and sort of current and past human thinking, which makes it very difficult to innovate or to create transformation beyond what we've seen so far. So some of what's beginning to happen is we're shifting from large language models as training sets to first, they're large multimodal models. So they're being trained on images, they're being trained on video. So that's beginning to come out even in, you know, ChatGPT and Copilot and those. You're starting to see that multimodal way of interacting with generative AI. But what comes after that, I think, are two things. One of them is what's called a large action model, which is trained not just on static data, but on actual things that happen. So when Philip and team plants a tree and it grows over time, we would be looking at the data of that whole growth and then starting to train AI and asking, how could we do that better? How would you optimize that process? So it's going on actions instead of just on static text or images. And then the sort of top level, this is a little framework we're talking through here. I think it would be really interesting if we trained large models on ecological systems. If what we're looking to do is regenerate the earth and her systems and her people, then actually the data we should be using should come from ecological oracles as opposed to just from the text that humans have already written out there. So that's some of what I see for the future, is that the models will be trained on ecological data, some of the likes of what's being gathered here, some of the actions that regenerative agriculture is happening in the world, and we'll see what happens. Okay, How well do you think that regulatory disclosure requirements are capturing biodiversity metrics? Let's do like a one or two words. How well are they doing right now?
Not particularly well yet.
Got it. Agreed. Anybody else got a different answer? I mean, we're seeing, yeah. It's like there's a little bit in the voluntary disclosure with SBTN and TNFD, but regulatory, a little bit CSRD is starting to get there, but we're not far enough yet. Do you all see an opportunity? This has already somewhat been answered, but we'll give it one last go here. An opportunity for on-the-ground farm equipment to contribute to biodiversity data at scale.
Absolutely. Pull some sensors into everything that's already happening, and we can make it extremely scalable. I think there's a ton that can be explored here, and it's really exciting to consider what that could look like.
Did you hear that, John Deere? Let's do it. Any other last thoughts here from our panel? All right, well, I just want to thank you all for being here, showcasing your solutions, doing the great work that you are doing out in the world. Thanks for coming to the AI for Biodiversity Solutions Showcase. And if you enjoyed what you saw here today, you might dig another HowGood webinar. We have a big one coming up on carbon footprinting, which is digging into the science, strategy, and bottom line payoff. That last bottom line payoff is pretty important. The ROI for this is huge. So that's not long from now, December 10th. We hope to see you there, howgood.com/events. Thanks again to our panelists and solutions creators, and see you all soon.
Thanks, everyone.
Thanks.